Hi guys, this is Achut. So we are going to be looking at the solutions, which is bi-weekly contest 1 to 4, and then we'll be going through each question, and then we'll be solving the solution for this. So we'll pick the first question. So it is a straightforward question. Like we are given an array which is nums, and then we need to let's yeah we are given an array of nums. You can perform the following operations while the nums contains at least two elements. So we are given nums, and then we need to do the operations till at least there should be two elements, and then we need to choose first two elements of the nums, and then we need to delete them, and then score of that operation is going to be the sum of the deleted elements. And then your task is to find the maximum number of operations that can be performed such that all operations have the same score. So let's take this particular example. Let's say we are given this particular array. Then we need to pick the first two elements, which is 3 and 2, and then we need to sum this. We need to delete this particular elements, and then this is going to be one operation. For this operation, the score is going to be sum of the two elements, which is 3 plus 2. And then we need to do this till it it becomes empty, or it becomes like one element, or it becomes like the score is different with the previous. So 3 plus 2, which is 5. Okay. So we'll remove this 3 and 2, and then we'll add the operation to 1. And then 1 plus 4, which is 5. So with the same score, this is with the same score. So we'll also delete them and then add the number of operations. And then we'll be left with only 5. So we cannot delete it. So the number of operations which is going to be 2. And then for this particular case, 3 plus 2, which is 5. Okay. The number of operations is going to be 1. First two elements will be 3 and 2, and then the score is 5. And then the leftover nums will be 6 and 1 and 4. And then we are unable to perform any number of operations. Why? Because 6 plus 1 is 7, and then 3 plus 2 is 5. So 7 is not equal to 5. So that's why we are going to say it is not possible, and the number of operations which is done is 1. So as we can see, it is like the time complex, the length is 100. We can perform with more time complexity as well, it will pass. But the efficient approach is we'll store the previous whatever the sum, which is going to be at least one operations will be done. Why? Because there is no restriction on the sum. So the whatever the element which is present at the first two elements, that is going to be the previous score, and then we'll store the answer in answer as answer, and then we'll go through each particular number, and then we'll check if both are same, the score of the current operation and then the previous operation is same, then we are going to add it to the operation. Otherwise, we are going to break and then return the answer which is present. So we are just checking the answer with the we are checking the score with the previous score. If it matches, then we are going to increment the operations, and then we need to do the transition from I to I plus 2. Why? Because we are doing it for two elements. We are taking I, and then we are taking to I plus 1. So let's run and submit. So the time complexity for this is going to be big O of n, and then space complexity is big O of 1. Why? Because we are not using any extra space. So that is it for the first question. So let's go through the second question. Yeah, let's go through the second question. So the question states that we are given a string. Apply the operation to make the string empty. So you are given a string s, and consider performing the following operations until s becomes empty. So we need to keep on performing the operations till s becomes empty. So for every alphabet from A to Z, remove the first occurrence of that character in S if it exists. So for every operations we can delete every alphabet character that is present from A to Z, and then we are given example A, B, C. We can do the following operation. Remove the underlined characters. A, B, C. It is removed and then resulting character will be this. And then after one more operation is being done, we'll be left with B, A. And then after this, the leftover will be B, A, and then the resulting is empty. So we need to return the value of the string right before applying the last operation. So this is the last operation. Before applying, what is the answer? That is BA. So we need to return that. So let's say this is a particular string. So we need to return this. So how can we solve this particular problem? So let's take example of the same string. So let's think in terms of frequency. So it is going to be A, and then it is going to be B, and then it is going to be C. So we need to find the last characters which will be present. When can we say the last characters will be present? Irrespective of whatever the operations which will be done at the first and then at the starting. So if we see the frequency of A, it is going to be 3, and then if we see the frequency of B, it is going to be 3, and then if we see the frequency of C, it is going to be 2. So when the operation goes on, like there will be, whenever operation is being done, there can be A, B, C till Z. So for each operation, each operation, we will decrease each character present in the string. So for each operation, we will be decreasing the each character present in the string. That means we are decreasing the frequency of the character which is present in the string. So at last, we'll be left with the characters which has the same frequency, but that should be the maximum frequency. So suppose let's say at the first operation, the number of characters is going to be 2, and then for this it is going to be 2, and then for this it is going to be 1. For the next operation it is going to be 1, and then for the next operation it is going to be 1, and then for next operation it is going to be 0. And then for this particular case it becomes 0, and then for this particular case it becomes 0, and then for this particular case it will be 0. Why? Because we cannot remove if it is already empty. So before this is the last operation, 0 0 0 0. Before this last operation, there is one more operation which will be doing at the last. So this is the string which we have right now. So let's say it will contain A and B. It will contain A and B, but in what order? In what order? It can be A B, it can be B A, right? It can be any of them. So it is given that every character from A to Z, remove the first occurrence of that character. Suppose let's say we have A, A, and then A. This is 0, 1, and then 2. So at first operation, which A we will be removing? We'll remove A with the index of 0. Why? Because this is the first character which is A. So we'll remove the first occurrence. So that is going to be 0. So at the last operation, it is going to be the, for each character, the last occurrence of the character, it is going to be present before the last operation, right? So each character, the last occurrence of character in the string, it is going to be present before the last operation. So I am going to say that the last character which is present in the string, that particular character is going to be present at that time. So we'll be doing the same thing in the code. So let's go through the code. So I'll be storing the frequency for each particular character which is stored in A, and then I am assigning it to 0, and then I am going through each character which is present in the string, and then I'll increment, and then I'll store the maximum frequency which we have right now for the each character, and then we'll be storing into the maxi, and then I'll be storing the answer string in answer, and then I'll be starting iterating from last character of the string, and then I'll go till I minus minus. Let's say the frequency of the particular character is maxi. Then we can say that this particular character is going to be present, and then this is going to be the last character. Why? Because we are traversing from a back of the string. So we are going to consider this, and then let's say we have visited this particular string here. Then we need to take care of the character which is the same character which is present previously. So that's why we are assigning the frequency equal to 0. So whenever we meet with 0 with maxi, then we will not be storing it again. So I'll be pushing to answer, and then at last I will be reversing the answer, and then I'll be returning the answer. So let's try to submit this. So we just need to take care of the frequency and then the last character by traversing from the last character of the string, and then at last we are going to return the reverse string. So that is it for the second question. So let's go through the third question. Yeah, this is the third question. Given an array of nums, you can perform any of the following operation while the nums contains at least two elements. Let's say choose first two elements of the nums and then delete them. Choose last two elements of the nums and then delete them. Choose first and last elements of the nums and then delete them. The score of the operation is sum of the deleted elements. Your task is to find the maximum number of operations that can be performed such that all operations have same score. So we need to do these particular operations, any of these particular operations, and we need to make sure that score of the operation is going to be the same as previous operation. And then we need to return the maximum number of operations possible that satisfies these particular conditions. So let's say this is the array which is 3 2 1 2 3 4, and we need to perform these operations, and then we need to return the maximum number of operations which is possible. Let's say we'll pick 3 2. So the score for this is going to be 5. So whenever we do this operation for other operations, the score should be 5. And then let's try to delete the first two elements with the score of 5, and then the array becomes 1 2 3 4. Okay, and then delete the first and then last elements with the score of 5. Again we are going to pick 1 and 4, and then the score is going to be 5. we are maintaining the same score, and then leftover will be 2 3. And then again we'll pick the first and last elements, or we can pick the same, like as it is like first and last, and then first two last two both are same, so it is going to be any one of them operation, and the score is going to be 2 plus 3, which is 5. And then the array is going to be empty. So the number of operations which we had done is 1 2 3, so we are going to return 3. And then there can be, let's say we'll use 3 and 2, and then again we'll use 1 and 4 for the second operation, and then we'll be left with only one character, what do we say, one number. Then we cannot do the operation. Why? Because there should be at least two elements to do the operation as it is given, and it is as it is given. So we need to solve this. For the first question, it is given that we can do the operation at the starting, and then we should we should make the score same for when we want to remove. So that is one iteration which will be doing from starting, like 3 2, and then 1 2. If it is not same, then we are going to return. If it is same, we are going to just move in one particular operation. But here, if we take this, for this case, there can be three scenarios, three cases. First case is going to be pick first two elements. Second case is going to be pick last two elements. And then third case is going to be pick the first and then last element. So these are the three cases which we can do for this particular array, right? So let's say let's perform the first operation. So if we perform first operation, let's take state of array in terms of I and then j. It will start at I and then it will end at j. Now for this particular case, if we can maintain the same score, then the number of operations is going to be 1. And then as we are saying that we are picking two elements, which is I and then I plus 1. So for the next iteration, it is going to be I plus 2, and then j will be same. And then for this particular case, it is going to be I, and then the state is going to be I and then j minus 2. This is the state. And then for this, it is going to be 1 plus I plus 1 and then j minus 1. So here we are just taking the state of array. We are not taking any sum or doing anything. We are just taking the borders, which is like I and j. So let's say the I is 2 to 3, which is 1 and 2. Then we are going to say only this particular array we are considering. So if it is from 0 to 1, if it is from 1 to 3 4, if it is from 1 to 4, then this is going to be the case. So we are trying to remove the numbers which are present at the first and last. So we can pick this particular case and then we need to maintain the score as well. So we need to consider score as well. So what are the different scores which we can maintain? As it is given that the score should be remain same. So there can be only three scores, which is when we pick the first two elements, there can be one score. And then when we pick the last two elements, then there can be one more score. And then when we pick the first and last, there can be one more score, which is sum of the first and last element. For this, it is going to be sum of the last two elements, and then for this, it is going to be the sum of first two elements. So we are going to consider these particular cases with score. It is going to be score 2, this is going to be score 1, and then this is going to be score 0. And then there can be scenarios like we need to maintain the DP. Suppose let's say the problem is already solved for this particular case with the score of 3. Then we can say that if it is already solved, then we can say just return the DP. So we are going to store DP of I of j, and then it can be 0 or 1 or 2. If it is 0, then we are going to say this is a case. If it is 1, this is going to be the second case, and if it is 2, it is going to be the third case. And then we'll be maintaining this DP case, and then we'll be doing the transition for all these cases. And then out of this case, we'll be getting here score. This can be answer 1, answer 1. This is answer 2, and then this is answer 3. So out of all these answers, we are going to maintain the maximum of this answer, and then we are going to return the answer. So let's walk through the codes so that we'll understand better. So I'm just going through the elements and then I'm marking the DP to -1 so that the problem is not already solved. And then I'm going to take three sums, which is going to be considering the first element, considering the last two elements, considering the first and last elements. And then I'm assigning this same thing. So consider the last two elements and then consider the first two elements and consider first and last. And then if we do the operations, then it is going to be 1 plus operations of nums and then 0 to n minus 3. And then here same thing, 2 to n minus 1, and then again here by picking the operations, and then we'll be reducing the constraint based upon the picking of the elements. And then we'll be going through the operations, and then if it is I greater than or equal to j, then we are going to return 0. And then if the DP problem is already solved, then we are going to return the DP answer. And then we are going to maintain the temp variable so that it will store the maximum of possible cases. We'll pick the first two elements. If we pick the first two elements, the score should be same, which is like I have given 0, 1, 2 for this indexes. I'll be storing in the sums. So we'll be comparing with the sums of indexes. If both are same, then we are going to consider this operation and we'll be maintaining the temp. Here the same thing. We'll be considering the last two elements. Here we'll be considering first and last element. So out of these three operations, we'll be maintaining the maximum, and then we'll be assigning the DP to DP of I of j of index to temp. And then at last we are going to return the answer. So that is it for this particular question. Let's submit this.